This video is brought to you by Sporlan, quality, integrity, and tradition.
Today we have a call that the AC is leaking water, okay? Let's open this up right here. Yeah, that looks like it's gonna be a problem. Let's open this up right here. Oh yeah, don't you know? That's interesting, right? All right, here's the problem. These are my returns, and there's no access to get and move the returns. And if you look up into here, it's a super ridiculously tight attic. We need to run the returns to the other side of the kitchen, and I'll explain why. But you can't. Here's the deal. That's a zone sensor for the AC. It doesn't look like it, but it is. And it's in the most inconvenient place in the kitchen. It's the hottest part of the kitchen. And the AC is basically just never shutting off. What we really need is return over here, but there's no way to get the return through the wall over into this area for their kitchen. It's just an absolute horrible install. This AC just, it's hard for me to show you guys, but the return is in the coldest part of the kitchen. The manager says that, because and that's the other thing too, I can't really take you in the office, but they have the thermostat set at 69 degrees. And I'm like, you can't set it that cold. And she goes, well, here's the problem. The cook's line is super hot, but the back of the kitchen where the returns are is freezing cold. And I go, yeah, because there's no good return path. And that's the problem. The return air is pulling, 68 degree air, but the cook's line is 20-25 degrees hotter because of all the cooking appliances and the refrigerators and everything they have in there. So it leads this unit to freeze up. Now, of course, we're going to check to make sure that's the only problem, but yeah, that's going to be it. So I'm setting this unit up for defrost. I disconnected the compressor contactors, opened up the outside air dampers as much as I could. They won't, it's not a very good economizer, so it won't do 100% outside air, but open up the outside air dampers, and we're just drawing air in from the return, melting the ice. But while I'm up here, this dang walk-in freezer right here is making it's like a pressure control's going bad or something, because it's like click, 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 turning the compressor on, off. There you go. Sketching me out, so I'm gonna have to make a work order for that too, because that's going to end up being a walk-in freezer compressor if they don't fix the problem now, whatever the control voltage is. Pulled the cover on this freezer just so I can see it, but yeah, the contactor's like pulling in and out like a pressure control's being wonky or something. This is an old fan cycle switch that's not being used. It's been replaced right there. This is our low pressure. This is our high pressure. I tried tapping on them, and it's not doing anything, so I'll just have to monitor it while I'm working on the AC, figure out what's going on, because that's going to end up ruining a compressor. All right, so it's cycled back on. Condenser fan motor right here on the right is vibrating, so is the left one actually. I want to see this guy cycle off. I did go into the freezer and it's down to temp, so it's like it's satisfying, but then something's happening when it satisfies. I bet you we have a pressure control failing or something. But they are like, I don't know if I want to create a work order because it's working. The problem is it's going to become my problem on a Sunday night. But we'll have to see. I'll just keep watching it. Look at that. That's got to be a pressure control issue. Because it satisfies and then it like messes around. Yeah. They gotta create a work order. I'm gonna go tell them. So I said that I set it up by disconnecting the compressor contactor so that way the indoor blower motor is just running. The other thing I did was I took this door off and I moved it over, blocking the supply air side so that way it's not bypassing the coil very much. There's a little bit going by right here. And then that way it's drawing more air from here. And then I closed down the building damper as part of the economizer as much as it would go. So that way it's forcing the air through this section right here and defrosting that coil. All right, I talked to the manager and they're gonna go ahead and create a work order, so I told them they have to. All right, so here's what we did. I put service gauges on it. I've still got that unit over there defrosting. It's pouring water everywhere too, but there's not much I can do. All right, we're gonna push the contactor in. Oh, I turned it off. Okay, so actually, let's see, because it could also be a weak valve in the compressor. So Watch it come down, and let's see it satisfy on its own. Yeah, see, that's weird. So then I cut it lower. I'm holding it in. Yeah, it's a pressure control, because once it gets to the cutout, it like bounces, but if I hold it past the cutout, it stays. And it's not a weak valve because it's not bleeding back through on the suction side. So I need to replace this pressure control right here. Got a couple different options here, because we're gonna have to, I'm not gonna unsweat this. I'm not gonna go through all that hassle. So basically I can access via this port or this port. This port, it's gonna hit the panel every time someone opens it. This port, I can do it, and I just need to choose which one would be the best bet. A single, which is not gonna be the best bet. This is gonna be our best bet right here, because then I can put the pressure control right here going this way and out of the headache zone or whatever. I mean, I could do that too, I guess, but I like this method better right here. Use some Nylog on the flare nuts to lubricate the nut where it spins right here. And then personally, you don't have to do this, but I put a little bit on the threads too. That's just my preference. If you're going to use a torque wrench, you want to be careful about using this, because you can over tighten because of the lubrication that's on there. But anyways, so I did that. I've got to do some stuff to secure the sensing bulb so it doesn't rub out. Now I've got to run electrical from this control to here, but we're still able to put the high side on. That's all good. And then yeah, we're getting there. All right, if I did everything right, it's gonna work. So what I did was I went ahead and took one leg of power from right here. I don't have a schematic, I just did this in my head. So I took one leg of power from right here. This is line 3, power's off right now. It's running through the pressure control. Then it comes out of the pressure control all the way back down into here into a time delay. Then it comes out of the time delay and goes up to the compressor contactor. That way, if there's ever a problem with the pressure control again, it's not gonna short cycle on off. Now this is a 180-second time delay, which will be fine. I also went around with some silicone because I had to put a screw through here, glob of silicone on there, silicone down here, and right here to keep the capillary tube from the new pressure control from rubbing out. So I'm gonna turn it on and watch the cut in and cut out now. Power came on. Condenser fan motors are staying off until the fan cycle switch turns it on, probably around 250. Okay, they're on now. Now we're gonna watch the unit cycle, and it's gotta satisfy. And then when it satisfies, I hate that vibrating. When it satisfies, then we'll see what the cutout pressures are. Okay, let's see if we're in a pump down mode right now. It's dropping, but it could just be the way the system operates too. So a lot of times these units run lower than normal pressures because equipment's massively oversized. So I have it set to cut out around, I think, 10, somewhere in there, 10 PSI, 8 PSI, somewhere in there. These things are, okay, so we cut off at about 13 PSI. Now, it already turned back on, so we do need to adjust the differential a little bit, but we're off on time delay right now. I heard it click and turn back on. So we're off on the time delay. So I need to increase the differential on that guy. I made some adjustments, and what I did was actually disconnect the time delay just temporarily so I can actually see it cycle on and off and see what it's doing. Oh, this guy's gonna take forever to defrost. Let's see what we got going on here. I mean, it's getting there. It's getting there. It's making a mess down in the building though. Filters are still frozen in place. It's been defrosting for about a half an hour, so it's not too bad. All right, we're cutting out at about 8 PSI. And let's see where we cut back in. It's not even coming up high enough to cut back in. I have it set for about 20 PSI, which is about where the other pressure control was, so I'm pretty comfortable with that. This guy's back together, running like it's supposed to be. It cut back in at about 22 PSI. I'm fine with that. Everything is good, so I'm gonna get back to this AC now. I almost forgot to look into the contactor, and because it was short cycling, it's all burnt inside. I know it's hard for you to see, so I need to swap out that contactor. So I need, this is a 208 volt circuit, 208 volt contactor, 3-pole with box lugs on it. So I'm pretty sure I have one of those in my van. And it's a 61447 was the part number on it. It should be a 208 volt, 40 amp, with box lugs. Perfect. I always try to keep the most common items, so I'll have to replace that pressure control right there, and then this guy right here. All right, now we got the old contactor right here, the new one right there. Let's hope nothing blows up. This stupid disconnect is another thing I need to fix. I gotta fix that too. Gosh, one thing after another, right? Told you I'd win. All right, I got it remounted. Really need to fix that permanently. It's not the greatest that it's drilled into the wood, but we are back in operation, and now I can finally get back to the AC. All right, I went and got lunch, let this thing keep running. It's just about defrosted. Inside here, all the ice is gone. There's just a tiny bit back in here, just sitting on the damper. Now here's what I'm doing. I'm gonna go ahead and install freeze thermostats, one on each circuit. This right here, if the temperature of this line gets below 30 degrees, it shuts the unit down, or shuts this circuit down. And we'll wire that into the compressor contactors. This is a quick, temporary solution until the customer lets us figure out a ductwork solution. Now, I don't think there's anything inside the building we can do because of their low profile roof. So, yeah, I don't know. This is gonna be an interesting one, to say the least. I mean, this unit doesn't have the capability of doing side shots. I mean, I guess it does. If you eliminate this panel, we could do that. But yeah, we could. We could do a side shot right here and drop it down over here, which is in the cook's line. But this isn't anything that I would do on my own. The customer would have to get roofers involved and contractors to cut into that roof. I'm not about to cut, 24-inch holes or anything into the roof. So, but anyways, this freeze thermostat situation should be able to help temporarily. All right, I've got the freeze stats both wired into each circuit. I've got a thermostat wire safely ran up this suction header, but it's double zip tied, so it's not touching it. All the way over through here, actually going down through there, into here, and we're wired into each compressor contactor right here. So it's just breaking the power for the compressor contactor. I'm gonna go get my probes, and we're gonna probe up on this guy and do a full evaluation on the refrigeration circuit. I got all my probes on. It's always best I just sanded everything up, because the field piece probes, they need clean copper. We're ready to turn this guy back on. I went ahead and put new filters in it too. When I was out at lunch, I got some new filters because the other ones were trash. They were just encapsulated in ice. So we're gonna turn this guy on and watch it operate. I also still need to close the outside air damper, so I'll do that right now once I turn it on. All right, I kind of already had an idea what was going on before I came here. I started thinking about something. Without context, you guys don't know that I'm pretty confident there's no restriction in the metering device, okay? This unit has an Accurator metering device, meaning it has a liquid header, and the metering device is right at the inlet of this tube right here. So this tube is cold, but over here is warm because that's the liquid line, okay? The way that I installed the freeze stats, if we have a plugged up metering device, that freeze stat will open up, okay? And there's individual metering devices for each circuit, so it theoretically could shut the system off just if one circuit was restricted or something, okay? But just keep that in mind. I already knew that I don't think that's the problem. We've had a history. The squeaking sound you're hearing from the indoor blower motor, it needs new pulleys. All right, so let's come over here. Let's have a look at my app, okay? My app is basically telling us for the first stage, we've got about 6 degrees, 7 degrees superheat. Subcooling looks pretty good. Let's go through here. Outdoor air temperature is about 90 degrees. Discharge line temp's good. But look at that return air temp. 69 degrees, and I guarantee you the thermostat's reading 80 degrees right now, because it's pulling the return air from the back of the cook's line, where there's like 6 supply grills and 3 return grills, and that air just recirculates, okay? Then they're pushing air right in the cook's line too, but they're not getting any return air, and it's like almost impossible to get return air inside the building unless we ran ductwork exposed. There's no room in their attic, okay? So let's go ahead and go on over to our second stage, and let's go and see what second stage is doing. Now, second stage, superheat's a little bit higher, but keep something in mind. The outside air damper's slightly open, okay? So that's gonna make us have a higher than normal suction temp, okay? Refrigerant pressures, I mean, don't look too bad. We have a low saturation temp on the low side, but that's because we have a 69 degree. If we look at what our target is for the low side, it's saying our design target is 34 degrees for the low side temperature based off of our indoor ambient temperatures, okay? And we have 30 degrees saturation. I'm not too worried about that. I also think we have restricted return air ductwork also, okay? Like they undersized the return. Superheat, I'm not too concerned with that on this guy. Running about a 30 degree evaporator. Let's scroll on over. Outdoor ambient, look at that, 69 degree return air. And our temperature split is 25 degrees. What are we calling for? When we click on it, 24 degrees, so that's not too bad. Airflow is okay. It's a little on the low side. Again, I think we have a restricted return air damper. And in fact, I probably, before I leave, will go ahead and open up the outside air damper a little bit more. Now, so I don't see anything wrong with the refrigeration circuit, okay? We're a little bit low on our saturation temp for the first stage, but I mean for the second stage, but the first stage is at 31 degrees right now, right? So it's just about below freezing for the saturation temperature. 12 degrees superheat, 11 degrees superheat, it's coming down. I'm not too worried about the operation refrigeration-wise of this unit. It's just that we don't have a good path of return air that's causing the unit to get ambient temperatures inside the kitchen, okay? And the customer, like I said, had the thermostat set at 69 degrees. So that's why I went ahead and installed the freeze thermostats on the first and the second stage that'll shut off the contactor. Now I started thinking about something else. I'm gonna go ahead and put in the delay timer on each circuit, just like I did on the walk-in freezer. So that way when it does freeze, because when it shuts the unit off, man, it's gonna come up to it's 30 to 45 degrees. It's gonna come up to 45 degrees the moment it shuts off, like when the air temperature. So it's gonna short cycle on, off, on, off, on, off, and we don't want that. So I'm gonna put that delay timer. I'm gonna go make sure I have 2 of them, and we'll put 2 delay timers, 1 for each circuit. So that way, if it goes off on freeze stat or freeze lockout, it'll shut off for 180 seconds, then turn back on, right? Give it time to make sure that we thaw anything out, and then it'll run accordingly until it needs to. So until the customer makes a permanent decision on how they want to approach this, I'll be honest with you though, I wouldn't be the least bit surprised if they don't do anything after I get done with what I'm doing today. This unit has been in this restaurant for many, many years. Now, it just became a really big problem because they remodeled their kitchen and added a significant amount more of cooking appliances in their kitchen. And that's why we're having the freeze up problem so much as we are. It's just consistent. So this is our solution for this guy for now. So I'm gonna go see if I have those lockout timers real quick. All right, this unit is back up and running. I installed freeze thermostats inside the evaporator on the first and the second stage. And then I also put delay on brake timers and set them for the maximum 10-minute time frame. So the way that these work is when and if the freeze stat opens up and it breaks power to this timer right here before it goes to the contactor, this timer then activates a 10-minute delay timer that won't let it restart for 10 minutes. So not only does it have to satisfy warm up so that way the freeze stat closes, but then it has a 10-minute time delay built into it. So that's all we can do on this guy until they make a decision on how they want to permanently address the ductwork issues. That's pretty much all I can do for this guy.
Sometimes you run into these strange problems. I wish I could show you guys more of like the kitchen and stuff, but there's just too much stuff that can't be seen on camera, basically. Okay, too many things identifying, and yeah, I just can't get into that. But that attic is completely inaccessible. The main thing is what you guys saw of the returns. You saw a couple flex drops, right? First off, that is a 17.5 ton unit. Okay, I think they probably had maybe 3 18-inch flex ducts going. There's definitely not enough return for that AC. Okay, there's no way, right? And it's bent in a weird way, and just there's no way there's enough return air for that AC. But the rest of the attic is full of sheet metal, rigid, basically supply duct. The supply duct is taking over the entire attic, and there's no way to get around it. The little bit of space, there's a possibility maybe I could get like an 8-inch duct or something, but that's not going to do anything. Plus, in order to run a duct completely around to the other side of the kitchen, it would literally be like a 60-foot run by the time you go around everything, even if I could. And there's no way that there would be any airflow by the time you do that. It's just a horrible design. There's a couple restaurants of this particular restaurant chain that I service other ones that had very similar issues with the design of the kitchen and the back of the prep area being really, really cold. It's just a flaw in their design. This is the worst though, because just, the other ones we've been able to update things and change things and run ducts and things, but this one, they just have no room in this attic. I could take the zone sensor and move it into the back. Like I could do that, but then they would have absolutely no cooling for the front kitchen. Like that would be miserable. And then it's just a horrible situation here. So running the freeze thermostats like I did, it's not ideal, because if you have a restriction on the actuator metering device, you're going to get low temperatures on those return lines going back to the suction header, and it's going to cause the unit to shut down. But again, there's not very much I can do. So I ran the freeze thermostats, one on each circuit, or one on each stage, first and second stage, and then put the delay timers at the max time. That's really all I can do until the customer makes a decision on running a return air duct exposed on the roof, dropping it down into the cook's line. And even that, I didn't lift up the ceiling tiles in the cook's line. I don't even know if I can access anything in there, because they might have ran rigid trunk lines for the supply ducts in there too. It's just a horrible designed system. Like, it's horribly designed. It's just, sometimes you run into this stuff. There's only so much you can do. Okay. I mean, it is what it is, right? I'm trying my best. Next thing is the walk-in freezer. Big picture, right? So I just happened to be working, waiting for that unit to defrost, and I heard that walk-in freezer cycling on, off, and I was like, man, that can't be good, So luckily I caught that problem too and convinced the customer to make a work order so I could dig into it and take care of that problem. So we put a new low pressure control on there. No need to do anything else on that. Put the delay timer, and all is good with that too. So I really appreciate you making it to the end of the video. Thank you so very much. If you haven't already, please consider checking out my website, hvacrvideos.com. Merchandise available on there. We are running really low on the flex fit hats with the curved bill on them. If not completely out of stock, we're like right there. But I do have a restock coming in the next couple weeks, hopefully. I just got an email saying it was going to ship in like a week or two. So we should have those hopefully by the end of the month. So stay tuned. But there's all kinds of other merchandise available on there. We also have a restock of a bunch of other merchandise that's coming. We have the what do you want to call them? The beanies with why can't I think of what type of the beanies that fold over? For whatever reason, I can't think of the name of the type of the beanies. I don't know. I can't think straight right now. But anyways, we have new beanies coming. We have some restocks of shirts coming. So stay tuned. Those will all be available soon, again, on my website, hvacrvideos.com. So if you're interested in supporting the channel, going to my website and purchasing some merch, that's a great way. Another couple other ways to help support the channel. If you're interested in purchasing any tools, go to truetechtools.com. If you use my offer code BIGPICTURE, one word, you will get an 8% discount on majority of the items on the website, okay? Not all the items, but majority of the items, you'll get an 8% discount. And when that works and you get the 8% discount, I get a small commission from that too. So that's a great way to help support the channel. That's at truetechtools.com. The easiest way, though, really the easiest way to support the channel is just watch the videos from beginning to end. That really is the easiest way. Cuffed beanies. There you go. Cuffed beanies. We have cuffed beanies coming, because right now we have non-cuffed, but the cuffed beanies sold out last winter. I just ordered a restock of them, so those will be there soon. A couple other ways to support the channel: PayPal, Patreon, YouTube channel memberships. There's links in the show notes of this video if you're interested in doing that. Again, thank you so very much. I really appreciate you, and we will catch you on the next one, okay?